Hello, hello. Welcome back to another edition. Yeah, any questions from anyone before we get started? I guess we don't have any assignments or anything. So I was in office hours today for like 4 hours. No one was there. I guess Michael was there. Yeah. Okay, a few people were there. I'm sorry.
What times are your office hours?
They are 12 to 4 on Mondays and Fridays. So 8 hours of office hours. For anyone that's emailed me over, I guess, if you email me on a late Monday night or on a Tuesday, Wednesday, or Thursday, I will probably not respond. So for those who I haven't responded to, I will be responding late tonight or Saturday, Sunday, just because I'm working and it's hard to kind of...
You can email me, though.
Yeah.
And, I know where it is.
Yeah, Ken knows where I live, so he'll find me. Okay. So some announcements. A bunch of folks have been asking about books. There wasn't any... Well, we didn't have any particular books in mind for use in the course, but this is a book that when people do ask me, I recommend. I haven't read it cover to cover. I owned it for about 5 hours on, a week ago, last week sometime, and then I gave it away to someone because they needed it more than I did. So this one's pretty good. I haven't met the first author, Dave Mark. I have met Jeff LaMarche. He's really nice, so buy his book. It'll help you out, I guess. The other book that folks that I've seen used is this particular one. This book basically takes the approach of sort of like you're a beginner programmer. You haven't programmed in any particular language, and this will kind of get you started. So a lot of the books on Objective-C will assume that you already know C or C++. This one does not assume that. So if you're in need of a book, this will help you out. Anyone need to see one more time? And I'll send something to the news group about it. The next little announcement is about the Big Bang competition. If you've never heard about it, I guess this is the 10th annual one. The folks over at the MBA school hold this competition where they get folks together and they try to, they put together a business plan, and they, the best ones are, sort of, some number of them are selected, some number of those are then selected to present to some VCs, and whoever wins gets like 10 grand or something. And besides that sort of stuff, it's a good opportunity to learn about the world of business and being an entrepreneur and some of the things that you have to go through with that kind of stuff. It's a good chance to learn and meet a bunch of folks over at the MBA school who, I'm sure they're dying to meet you, because you guys, you're the folks making the products, and you definitely need them to sort of help you promote your products, which a lot of the folks I know, one of the biggest issues with their iPhone application stuff is how do they promote it, which was easy when there were less than 1,000 applications in the App Store, but now with 85,000, there's still only, 10 in the top 10, no matter how many more apps come in. So there's, I guess tonight is the night to the last day to RSVP by. So I sent something to the news group about this, so you can just follow the links from there, and you should check it out. If I was in town, I would totally go, but it's on Wednesday, so I'm not going to be here. One last thing, I guess I don't know if it'll be this quarter or next quarter, but over the next few months, they'll have a number of guest speakers come in to tell you about intellectual property and various legal things associated with business and financing and all that sort of stuff. So it's better to learn this now, instead of when you're actually doing your own startup and it really costs you money to learn these things. So learn it now. So today we are going to do a little bit more Objective-C. I know I promised that we were going to get all crazy this time, and we're actually going to get all crazy next time. So we're going to look at a little bit, a few more Objective-C things, and a touch of Objective-C++, just because everyone in here knows C++, or most of the folks. You might want to be able to leverage some existing libraries or some open source stuff that's in C++. And Objective-C plays nicely with that, as long as you know a few simple rules. Okay, so Objective-C properties. So last time, before we finished up, somebody asked about setters and getters. I don't remember who it was, but somebody asked about them. So basically, when you have some sort of object, oftentimes you want to be able to set and get the instance variables that are within the object. So Objective-C has a mechanism called properties that basically will let the compiler generate these setters and getters for you, just because more often than not, they're all pretty similar. So it'll save you some time in terms of writing the same stuff over and over. And these properties, basically they have some behaviors that are based on a set of attributes, and we'll take a look at that. And that sort of involves, is this property readable, writable, read-only, and then there's some memory management type things that are associated with it as well. And again, I know I tend to speak softly, so if you can't hear me, just say something and I will speak up. And actually, I should rotate this way again. Okay, so we're going to go through a bit of code real quick, and my little warning here is that this code has some memory issues. Basically, I'm not really following the rules in terms of making sure that we do what we're supposed to do. But for the purposes of learning about setters and getters, this will be fine. And then once we see the properties, they'll sort of take care of that stuff for us anyway. So first off, we have a dog class. And so if you remember from last time, in order to set up a dog class or set up an object, you have this @interface keyword, the name of the class, and then whatever you're inheriting from. And then in this case, our dog has a name and an age. And what we'd like to be able to do is access the name and the age outside of the object through some sort of a method. So what we can do is we can go ahead and declare these setters and getters. So first off, we have name, which when called will return this NS string that is the name. Or if we want to set the name, so that we can actually just say set name and pass in the name of our dog. And then we have the same thing for the age. So we can say age, that's our getter, set age, that's our setter. And if we look, we jump over from the interface to the implementation file, we see that we have all our methods implemented here. And first off, we have the name, and all we're doing is simply returning the name. So pretty simple, pretty straightforward. You've probably done it a million times in C, in C++. Okay, so we have the equivalent set name. Again, we pass in our parameter new name and just assign it to name. And then we do exactly the same thing with age. So before I go on, is there anything strange looking, I guess, about anything we see here? So last time we sort of spent time just kind of looking at the syntax of Objective-C and how you sort of set some of this stuff up. Is there anything strange that, yes, Sonny?
There are no access modifiers, so are these by default public?
Right. So so basically, in terms of access modifiers, so from C++, you're used to having stuff like private and protected and public, and you actually have the same sort of thing. And I've just moved back to the interface file here. You have the same sort of thing going on in Objective-C, except those sorts of things don't apply to the methods. So if you look up top, we have interface dog, and then there's that block that contains the instance variables. Well, by default, those are protected. So the keyword is actually at protected, and you could use something like at public to just open that up, or at private to prevent folks that inherit from you from accessing those directly. So the rules are pretty much the same as what they are in C++. But when it comes to the methods themselves, they are, at least the way I'm showing them here, they are always public. And when we get to categories, which is something we'll discuss a little later, if I forget, remind me, and I'll show you how we can actually hide methods that we don't want people to be able to get access to. Any other questions? Anything strange? Syntactically, something bothers you? It's all clear, straightforward. Okay. So now that we have our implementation, let's go ahead and instantiate a dog. So we have our dog pointer, and we then have this method passing, or this method calling, or message sending mechanism that Objective-C has. So we have our dog class, and we're sending it the message alloc, which allocates whatever memory we need, and then we're sending that object this default initializer, which comes from, in this case, is from NS object. So to use our setters and getters, we basically just send some messages. So dog set age, and let's say it's 5. Dog set name Woofy, and then to actually to use the getters, let's do some NS logs and dump this to the console and say NS log name equals whatever, and then we can we can send the message name to dog to get our getter. I hear lots of typing and stuff. Okay. Are you going to check to see, make sure it runs?
Yeah. Make sure it'll build.
It runs, I think.
Along this company, so I'm trying to get some of that too.
Okay. Well, yeah, a little later, we'll see how quickly we go through this stuff. And as I mentioned last time, we're going to be sitting down and coding and doing some stuff. So we'll see. Yeah, that'll help you out. Yes?
If I wanted to run into the hello
So to get this stuff to actually run and show up, do you want it to show up on the console, or you actually want to show up on the little iPhone simulator?
Depends on which is quick.
So the code as it's written here, basically, if you have Xcode installed and you do a new project and just select the view-based application, what you'll have is there'll be whatever the name of your project is, appdelegate.m. Inside there'll be a method called application did finish launching. So you can stick this code in there. That's a reasonable place to put it.
Did finish launching?
Application did finish launching is what it should be called, yeah. And then somewhere near the bottom of it. And we'll be looking closer at that application did finish launching a little later today. Okay, so we saw how to sort of do it ourselves. Let's create our own setters and getters. Now let's go ahead and let Objective-C take care of the work for us. So everything's pretty much the same here. We have our interface dog, and we have our 2 instance variables, name and age. And in this case, instead of having those method declarations, instead what we have are these 2 property statements. So the first one is, at property, and don't worry about copy that thing in yet. But so we have at property NS string name, and then we have at property int age. So if you look, it's it's pretty much taking the instance variable and sticking the word, the keyword at property in front of it. And I still hear typing, so I don't know if I should hit the space bar, but I'll.
This is all online, so.
Yeah. So this is one of the things with slides that I really liked about the chalkboard back in the old days, is that it forced Ken to slow down. Like, he would have to write, and versus just throwing up all these equations and things. So, all right, well, we'll move on. So in the implementation now, minus this dealloc, which we didn't have earlier, things are much shorter. All we've done now is said @synthesize name and @synthesize age, and that's basically our way of telling the compiler, hey, go ahead and generate these setters and getters for me. So what we could do is actually set up the properties the way we did in the interface, and if we don't call these, if we don't set up these synthesize statements, we would have to implement those setters and getters ourselves. And there might be reasons you'd want to do that. What's nice about properties, which we'll look at in a little bit, is that you can set these attributes that sort of give you some information about how am I allowed to interact with this particular property. So another thing that's usually done with properties is making use of dot notation. So this notation is what you're used to from C++, where basically, we can now say dog.age equals 20. So that's basically what the compiler is going to do, is it's going to transform that into the message that that calls the setter. And same thing with dog.name equals Rex. So so those are our two setters on the first two lines, and then on the NS log line, we can actually, what will happen is those are actually the getters that end up getting called. So I'm going to back up a bit just so we can compare. So the first version of this, when we weren't using the dot notation, basically we would just send these messages to our objects, and with the dot notation case, basically the compiler will end up massaging this around and turning it into that the previous stuff. And actually, when you're using properties, you're not restricted to this dot notation. You could actually use what we had set up previously. So the main reason, I'm not a big fan of the dot notation. It was added to Objective-C 2.0, which is what we're all using now. Not that I used anything prior to Objective-C 2.0, but the dot notation feels, I don't know, just doesn't feel as pure as what was going on before, which I guess is fine. People that advocate for this, basically they say that this is just clearer to read. Your intentions are much more clear here, that, okay, you're accessing the property and you're doing some sort of an assignment, and that's actually, while the mechanism is fundamentally the same, the action is very different in terms of what you're doing. You're not really sending a message to an object, you're just setting something. Okay, so hopefully that's readable from way back in the back. So the property attributes, so when we have this keyword @property, in parentheses we can set up various attributes. Then we specify our property type and the name of that property. And in terms of the types of attributes that we can have, there are more than just these two. So I have writability and setter semantics. There's another one related to whether your property is being accessed in a threaded versus a non-threaded environment. So if it's an atomic versus non-atomic type of access, and I'll let you read about that because it's not quite so important right now. There's another one that lets you actually change the name of what the setter and the getter should be. So right now it's just defaulting to what the name of the property is. You can actually specify an attribute that lets you change the name. But for us right now, the more important ones are writability. So basically the writability determines what the compiler will do for you. Will it create both a setter and a getter for you, or will it just set up the the getter? So when you use if we were to say at property parentheses read write, that's sort of the default what's happening right now. That's basically saying, hey, create a setter and a getter. More likely, what you're likely to do is, for whatever reason, you don't want a setter. You just want people to be able to read your variable, and so you would just specify read only, and the setter wouldn't be created. And if someone tries to use it, you would get a compiler error. Now, in terms of this setter semantics, basically we can specify when you do this assignment or when you're accessing these properties, what's actually happening. Are you just doing, in terms of assign, just copying the bits over? So if you have an integer being assigned to a property that's an integer, that would just copy all the little bits. Are we doing some sort of a do we want a retain semantic? So we learned last time about some of the memory management things and how Objective-C, the memory model that we're using, is this reference counting mechanism. So what would happen here is when you assign an object to the property, it's basically just saying, here's another pointer that's pointing to whatever object, and because we're using this retain semantic, that object's reference count is going to increase. And then the other semantic we have is a copy. So, I don't want just a reference to some other object. I actually want my own copy. And if you remember last time, I had that acronym NARC in terms of referring to memory management and how we would deal with various things and what our responsibility was in terms of freeing the memory that we interact with. So we had NARC, which was new. We had the R and the C, the retain and copy, so new, alloc, retain, copy. So we knew if we ever used those directly when doing some sort of initialization or when we were interacting with an object, we were then responsible for doing something or releasing that object when we were done with it. So the same thing happens. The same thing will happen here in terms of retain and copy. If we set retain or copy as one of the attributes on our property, then at some point when our object is deallocated, we need to relinquish ownership of it by releasing it. So let's see. So an example of how you might use this, I should have made a longer one, I guess, but so at property read only. In this case, we're just, we can't assign. We're not going to be able to assign property names, so it's read only. On the second line, we have the at property copy. What we're saying here is when we're using the setter, we want our own copy of whatever object we're trying to assign to us. So like I mentioned, so in this case we have the at property copy NS string name. At this point where it says dog.name equals at rex, what we're doing is because of this copy semantic, we're actually going to create our own NS string, which is going to be contain rex. So at some point when we're done with our object and it's time to deallocate it, we're going to need to say name release to decrement its reference count. And then usually whenever we call dealloc, we also want to call our parents dealloc so that they can clean up whatever memory they need to take care of. All right, any questions about properties and attributes or any of that kind of stuff?
Question?
Yes.
Could you give an example of when you would use a copy versus retain?
Okay, so when would I use copy versus retain? So this is where it's depends on your application and sort of your knowledge about how objects interact. And for whatever reason, let's use this string example here. It just might not make sense for 10 different dogs to be pointing to the same name, because some owner, the dog changes owners, and the dog doesn't like Woofy, and they want to call it Floopy, and so they change the name, and now all 9 other dogs are named Floopy. So in this case, you'd want this copy semantic where where initially maybe all 10 dogs happen to be named Woofy. At some point, when somebody changes their dog's name, they'll be changing and modifying their own copy. So again, it's sort of just dependent on your problem at hand. There could be a situation where you really want retain instead, because the object either doesn't support being copied, or is just it's so huge that you really don't want to be copying it around. So maybe you have some sort of visualization problem, and you've got some huge data set, and it doesn't make sense to copy 5 gigabytes from one place to another, and you just would want to reference it. Okay, so properties, you'll be using properties all the time. Okay, so next up, we're going to look at some Objective-C language features, categories and protocols. So categories are basically a way of adding new methods to existing classes. So it could be classes that you don't have the original source code for, and so we'll take a look at some of that. And then we'll see, usually there's a certain naming convention that you use with them, just to sort of keep track of what's going on with them. So basically, in terms of syntax, to set up a category, it looks very similar to how you set up a class, except you basically put the name of your category in some parentheses. So we don't have any blocks, like we don't have any squiggly braces or any of that kind of stuff, because when you have categories, you can't add new instance variables. It's all about just adding methods. So in this case, what I've done is I say, at interface NSString. So NSString is not my code, that's Apple's code. But even though it's Apple's code, I can still open up that class and add my own methods to it, which might be useful for various reasons. And we'll see as we start diving into to Cocoa and the various libraries, we'll see that, and actually we'll look at an example for NSString where it has some category that where it adds some methods for doing whatever it needs to do. And then in terms of the implementation, looks pretty much the same as what we had before, except the name of our category is now in these parentheses. And in terms of the naming convention, you see basically the .h file is usually named whatever the original class was plus the name of the category that you assign to it. And then in this case, I just sort of named it the same. That wasn't necessarily important to have done it this way. But so let's take a look at an example. So protocols. Yeah. Okay, so from Xcode, we've seen this a few times, but if you go up to the upper right and developer documentation, that'll bring up, usually bring up something more like this. And from here, let's take a look at NSString. And if we look over on the left-hand side, so I have a bunch of sort of duplicate things because I have some different I have a few different SDK versions installed, but so we have NS string, and then if we look a little farther down, we see that we have this NS string parentheses UI string drawing. So this is Apple using categories to add some methods to their string class, which in this case, UI string drawing hints at user interface string drawing. So probably various, they have a number of methods that when they actually want to display strings in some sort of user interface, they'll use the methods from this category. So if we take a look, we get some information that this is NS string UI kit additions. So if we look at some of the things that they've done, well, let's see. So basically they say, this framework adds methods to support drawing of strings and to do some stuff with bounding boxes prior to drawing. Okay, that's cool. And so some of the things they've added, give me the size of this string with a font, and what that's going to end up doing is returning, some CG size, which happens to be a width and a height. So that might be important for you for some reason at some point. As far as me kind of walking through Xcode and doing this, it's more just to see, this is the sort of stuff you're going to be doing as you figure things out. And, when it's 2 a.m. and I'm not there, Xcode help will be there, and I'll probably be there too, but just in case. So some reasons that people use categories. So the first one, basically you can extend classes implemented by others. So if you and I wanted to make some additions to NS string, we could, even though this is Apple's code. We don't actually have the implementation. We have the interface file, so we can see sort of how some things work. But we can add sort of our own additional implementation. And what's interesting is this is sort of, it's an alternative to inheritance. So we could, so Apple could have taken NS string and they could have inherited off of it and created a new UI NS string or who knows what. But that's not, inheritance isn't always the best solution for them. In this case, the best thing to do was to simply add some new methods to their existing NS string class. Another thing you can do with categories is you can use it to distribute your implementation across multiple files. So if for whatever reason you just have this ginormous class, and you can sort of split it up by looking at, maybe there's certain methods that relate to some specific aspect of your object, and maybe there's 10 of those methods, and maybe you have 15 other methods that relate to some other aspect. You can label those methods using categories and say, well, this is the drawing category, and this is the, I don't know, whatever category. Yes?
What exactly is the difference between inheritance and categories then?
So
if they can be used, since they sound like very similar to me.
Right. So a main difference with categories is you cannot add instance variables. So oftentimes when you inherit off of something, you really care about the member variables, but you want to add some of your own member variables. So if that's the sort of problem you're facing, then inheritance would be the way to go, because categories only let you modify the interface or add to the interface. So, yeah. Yes?
Can you import multiple categories?
Can you import multiple categories? What do you mean?
So if you showed me that there's a UI string drawing, and then let's say if I have another one, I import both of those and use their methods for each category in my implementation.
Yes, yes. So in the end, like you saw how I set up that, I showed that convention of my class name plus the category name. So you might have, let's say it's NS string, and you have 5 different categories. So those are going to be in 5 different .h files. You can include all of those, and now you have access to all of the different methods from the different categories. And what you can also do with categories, and I haven't messed with this myself, but I know you can do it. You can actually you can use the category methods you declare to overwrite or hide other methods that are already there. So I don't know, maybe I could see a situation where, and it does happen, where there's actually, there's a bug in Apple code, and you're so rock star-ish that you're just going to overwrite their implementation, and that might be a use, which I believe you guys are. But the other way that we can use categories is to implement informal protocols, and we'll take a look at what a protocol is. For folks that are sort of from the Java world, protocol is, and I'm not from the Java world, but protocols are similar to interfaces in Java, if that helps anybody out there. And we'll look a little more closely at protocols in a second. But in terms of categories and me listing informal protocols here, it's basically categories are just, here's a list of methods that that someone could implement in terms of protocols. So what are protocols? I guess it leads right into this. So basically protocols are it's another feature of Objective-C that that lets you basically list a bunch of methods that somebody else can implement because they have to or they should implement in order to operate with some other thing. And actually, that's the next bullet, which is that protocols are often used to define interfaces for delegates. And we'll be looking at this over the next few slides and through some of the sample and through some sample code. But yeah, so we'll look at that in a second. I won't say anything about it now. So here's a protocol that I pulled out of some of my code as I was trying to figure out, kind of what sort of stuff to show you guys. So in terms of syntax, you have this keyword @protocol. You give it a name, and yeah, you can list your methods. And in this case, I have correct word, duplicate word, incorrect word, current word modified. So what would happen is if someone wanted to adopt this protocol, basically they would need to implement these methods for some particular reason. And when we look at delegates in a few seconds, we'll see that. So now I guess a few times we've started with Xcode and created a new project, and I think I've sort of I said ignore this stuff off to the far right, but this is basically how you adopt the protocol. So in this case, the name of the protocol is UI application delegate, and in order to say that my class implements or wants to adopt this protocol, you put it in the little angle brackets and state the name. Yes?
The NS object keyword there.
So in this case, so what we have is @interface, so we're declaring our class, my class, and it's inheriting off of NS object. And basically the way to, if we weren't inheriting off of NS object, we could just say my class and put in the angle brackets with the protocol. But yes? That's it.
The reason I'm curious is doing the impression that NS object is class.
Right. So NS object is a class, and it's just this is just the syntax for saying that my class happens to inherit off of NS object, and it happens to adopt the protocol from UI application delegate.
Okay, so UI application delegate is
is the name of the protocol. Yes, and that's a good good point to look at it. So, file, new project. We'll eventually learn what the view-based application is all about, but for now we'll just choose it. And my test thingy. So we see that one of the things that Xcode does for us when it basically sets up our template, it sets up these files, my test thingy, appdelegate.h and .m. And if we look there, oh. This is the .h. So if we look, right, so we have our interface keyword, the name of our class, my test thingy app delegate, inherits off of NS object, and adopts the protocol UI application delegate. So if you remember the protocol, and when you're in Xcode, and we'll learn more about this, I guess, as we go, but if you hold down the command key, which is the little open apple, if you hold that down and then double click, in this case over UI application delegate, it'll take us to the header file where this stuff's declared. So we saw earlier the keyword we used to set up our protocol is @protocol, and in this case it's UI application delegate. And if we, at the example I showed didn't have this other keyword @optional, but what you can do is you can say that some of the methods that your protocol defines are optional versus being required. So in this case, UI application delegate, if we look, pretty much everything in there just falls under the optional, nothing's required. And if we look a little farther down, we see there's a category as well that's set up, and Apple decided to name it UI application deprecated, and they'll do this from time to time, whereas as the SDK or as their interfaces evolve over time, they start phasing out certain methods. So in this case, they decided to put this method, which is it's just a property for proximity sensing enabled. So that seems to have been deprecated, which means you'll still be able to use it, but eventually at some point down the line, they might get rid of it. And so as soon as you sort of run into some of those things, and the compiler will tell you, you'll get these warnings that this thing is deprecated. And often, usually there'll be some sort of documentation saying, well, you should use this other thing instead. Okay, so we have a few other things in here, right? We've got things we talked about today. So we have some instance variables, in this case window and view controller, and then we've set up, they've set up some properties, and so I mentioned that there were a few other types of attributes besides the kinds that I was discussing, which was the writability and the setter semantics. In this case, we have what they're using is non-atomic. So what they're saying is that you don't need to do any special handling to make sure that, basically what it's saying is that you are not going to access this property in some sort of threaded environment where there's going to be some sort of race condition. So if you don't specify non-atomic, the little the setter that gets set up basically there'll be some code around it that's like, some sort of mutex or some sort of lock that will try to protect, well, that will protect that variable from multiple folks trying to assign to it at once. And usually, I think if I look through most of my code, I always have this, because generally I'm not trying to access my stuff from some other thread. And it's just like some sort of, it's a little performance boost. So, okay, so back to the protocol. So we're applying, we've adopted this UI application delegate. And if we look into our implementation, we see this method, application did finish launching. So in this case, what we've done is we've adopted this protocol, and then we've gone ahead and implemented this method. So this is getting us into delegation, which is basically, well, what is a delegate? If when we're talking about politics and stuff, I guess, President Obama might send, I don't know, one of us as a delegate, on behalf of the U.S. or on his behalf to go to some other country to try to set up whatever it is we're trying to set up, some sort of trade agreement or some sort of peace agreement. So Objective-C has something similar, where basically, in order to decouple classes from each other and sort of increase the likelihood of reusability, what you can do is you can use a protocol to define an interface, and then you can basically you can set up a delegate, which is some other object that adopts this protocol. And at runtime, when in this case it's the UI application delegate. So the application starts up, a bunch of things are happening. Eventually, the application, which is its own little object here, let's say it's UI application. When the application is done loading, we've somewhere set ourselves as a delegate. In this case, it's we're the delegate here, my thingy app delegate. And what UI application does is it says, okay, well, I know that the application is done loading. My delegate might be interested in knowing about this. So you basically say, it basically then calls a method or sends a message to the delegate. So UI application did finish launching. And so that's sort of our way of hooking in to the UI application. So when this class was written, UI application, it's this very generic class that represents applications. There are essentially an infinite number of applications that can be written. So, Apple has no way of knowing, well, what classes am I going to write when I write my application? So using this, using delegation sort of takes care of that problem where, Apple doesn't have to know about anything I'm about to write. And so at some point when the application is ready, it can just tell us, its delegate, to go ahead and do something on its behalf. And we're going to see this is something we'll be using quite a lot, just because, again, it helps decouple objects from each other in a nice way. Let's see, an example. Let's see, how about UI text view? So the other thing, so command, or the open apple, if you double click on something, it'll take you to its header file. If instead you press the option key or alt, you'll get like this little crosshair. You'll double click, you'll get this little bit of info about it, and you can jump to the to its class reference. And if we look here, what we should see is that there's some sort of delegate tasks. At least I thought it was in here. Well, so the UI text view has a delegate property. So this is how, let's see. So this is how something like UI application, the class we were looking at, or in this case, UI text view, this is the property that it would set up, where at some point we would tell the UI text view that we're its delegate, and we would do that using this property. And all this is saying is, so we have this ID type, which we talked about very briefly last time, which is just a generic type. It refers to any type. And what it's saying is, well, this generic type adopts the UI text view delegate protocol. So if in our code, we adopt the protocol, at some point we say UI text view dot delegate equals whatever our class is, then at some point in the future, when, and I guess we can look at it here, when the UI text view does something of interest to us, or does something of interest for us, we'll get a callback into our code. So the text view, if it's not obvious from the name, is basically just a text box. So what happens is, as you're typing in there, there might be, every time a letter is typed, you might want to know that a letter was just typed. So chances are good that in the UI text view delegate, there's some sort of method that relates to that. Or when I hit enter, which is essentially submit, again, I might want to know that the user has just hit enter, and using this delegate and these protocols, UI text view could let us know, so we can sort of hook in and do whatever it is we need to do. So UI text view delegate. So if we look over on the left-hand side in the tasks, so this protocol, let's see, what do we have? So we have some things relating to responding to editing notifications, responding to text changes, responding to selection changes. And then we see when we look in the documentation, there'll usually be some sort of info, whether it's an optional method, or in the case of text view should end editing, it seems like that one is not optional. You must implement that one. And you can see that through the documentation, or again, when I jumped into the .h file, we saw that the UI application delegate protocol had an @ optional for all of its methods, so we don't really have to do anything with them. If we jump to this guy, we'd see that they're separated a little bit differently. So let's see, what is text view should end editing? Again, from the name it seems pretty clear, but let's see. So return value, yes if editing should stop, otherwise no if editing should continue. Okay, so this method is called when the text view is asked to resign the first responder status. So that's starting to get a little too deep for what we've covered so far, but basically, as we start dealing with user interface elements, different elements will have focus. In this case, this text view element might have our focus in the sense that a keyboard is brought up. So at some point when we're done, we want to resign and say, okay, well, we're not focused anymore, kind of give control back to somebody else. Okay, so that was kind of a, I don't know, I think a roundabout-ish way of talking about delegates and protocols, but does anybody have any questions? Like, what exactly, was I clear in terms of saying what a delegate is and how we might use them? Does anyone want me to say it a different way, draw pictures, something, or it's just 100% clear? You can shout it out. I'll look away so I don't know who's... What's that?
Pictures are nice.
Pictures are nice? Okay. All right, well, I won't draw pictures this time, but next time. So I don't know if some of the Apple docs have some pictures of some of this stuff. They probably do. So, I mean, there's definitely... So this is basically, you know, this document here, the Objective C20, which from last time you were supposed to read like a bunch of stuff. It's pretty much the first few things up here. And let's see, there is a section where they actually discuss a bunch of the different types of patterns that we'll be using in Objective-C. So let's see, there should be a delegation pattern discussed. And maybe they have some images, if not. Not quite the patterns I was looking for. Cocoa design patterns. So there's a document, Cocoa design patterns, which gets into all sorts of useful things about all the different types of patterns that are going to be in here. Communicating with objects. So here's a section on, you know, delegates and data sources. Let's see what we've got. I'm going to zoom out real quick, see if they have any. Okay, so, you know, they have a little bit of a You know, I just realized I didn't change my resolution, but so let's take a look at their little example here. So in this case, they have a window, and let's see, 1 window should close. There's a delegate 2 does something 4. Well, I think we'd have to read it. You know, I suggest reading this example if you need to kind of get a better feel for at least what they're doing. I'll try to use their diagram just to, you know, in kind of my own words, what just to say again what delegation is and how it works. So in this case, let's say we have a window, and a window defines a protocol, or, you know, a set of methods, an interface that anyone that's interested in certain types of things happening, and for example, window should close, they could then implement that method and know that, you know, the window has done something and it should close. So since I've implemented the method in my class here, which is this A delegate, I can go ahead and do whatever it is I need to do in response to this window should close. So I need to stand. So again, the idea of the protocols and the delegates is basically we have some object that defines whatever interface others can adopt. When that object is doing whatever important work it's doing, there's certain situations where it doesn't know how to handle or do certain things. So that's where it's going to, you know, that's where the delegation comes in. It's like, well, I don't know what to do, but you're my delegate, you know, go and, you know, solve world hunger or fix whatever it is that needs to be fixed. And then, you know, do what you need to do, and then control will return to me and I will continue. Yes?
Is it like an abstract class?
Is it like an abstract class? Well, in terms of protocol, I guess you could think of it as an abstract class. Or any Java folks, when you have Java interfaces, can you actually instantiate an interface, or you must adopt an interface? You must adopt it. So with an abstract class, it is similar in that in the abstract class defines an interface and you can't instantiate it. But that's what a protocol is. But in terms of actually getting the delegation, you would need code that was written in some way that that refers to this abstract base class, so that when the code is running, it says, hey, object of type abstract base class, call virtual method, whatever, to sort of, to get that tie-in to your code. But did that make sense? Sort of, okay. So I think, as we go, we're going to see more examples of this, more concrete examples as we write some code. And for example, when we actually use UI text view, we'll see how, again, it defines a certain interface that we care about. We might care about when certain things happen, and when we do care about those things, we will implement them. And let's see. Okay. All right, so the last little bit is a bit of Objective-C++. So this, I'm just going to code just to show you how to use it. So like I mentioned at the beginning of class, Objective-C plays nicely with C++, and that's important because there are a ton of open source things out there that happen to be written in C++, or for whatever reason you have your own code that you would rather write in C++. Maybe it's certain very performance intensive code. So a lot of the games, for example, that are on the iPhone, they're just ports, and it's not like, how do these people get these games out the door so quickly? Well, it's not because they rewrote it all in Objective-C. They wrote as little Objective-C as was necessary, which is basically just to interface with, OpenGL, for example, and set up this application framework thing that needs to be set up. And then the rest, they just call into their code. And so let's see. And again, I'll do this view-based application. My CPP test. Okay, so let's just start using it. Does someone have a favorite STL container? No? Okay. All right, we'll go with vector. It's less typing for me. So, first thing we can do is just include a vector. I don't know. Let's see if this even builds. It shouldn't. So it didn't build. It's like, well, what's the deal? I told you to include my vector. I didn't instantiate one or declare one or anything, but what happens is when you use C++ with Objective-C, what you need to do, this is kind of like the first little rule, is, so we've seen so far that Objective-C, its implementation files have these .m extensions. So first things first, when you're using yikes. Okay, when you're using Objective-C++, I must click slower. Okay, when you're using Objective-C++, the extension on your files is .mm. So from that right there, Xcode knows everything it needs to know, and it'll see, file type is, the extension is .mm, call the Objective-C++ compiler instead. So if we build now, this thing should just compile. So basically, any of your .h files that includes a C++ header file of any sort needs to have a .mm extension in the implementation. So let's see. So we've got our vector. Let's go ahead and, so standard, so usual stuff, right? Get our namespace, And let's make one of ints. And we'll call it myvec. And we won't worry about any property type stuff. But I will say that in general, if you're using C++ inside of your Objective-C and you need to access it through some sort of property mechanism, you're not going to want to use retain. You're not going to want to use copy. You're not going to want to use those sort of semantics because those refer to things that that inherit from NS object. So C++ objects have no idea what does it mean to be retained or what this copy means. So it'll sort of be up to you just using the assignment. Well, you can just generate your own little setters and getters in that case. I think I've used properties with them in some of my code, but usually it's just sending with pointers, and I'm using assign because that's just doing a bitwise copy. And we can look through some of my code to see. But all right, so we've got myvec, and now it's just the usual. Actually, so we can open up the namespace in here, and we want to do that in here instead of the .h because we don't want to sort of pollute or open up that namespace everywhere. So myvec dot pushback. The other thing that's unfortunate is Xcode isn't as nice about sort of completing things for you. It knows a lot about the Objective-C stuff that's going on, and it'll happily sort of suggest things, but if I hit escape, which is sort of the little key that will bring up a bunch of options, it's just like, yeah, no completions found, which is a lie. But so pushback 1. It's weird. I saw it for a second. Pushback 2. Pushback 3. And so we're back in familiar territory for most of us, and the reason I'm showing you this, not necessarily because you might use some existing library or something, although you might. Well, you might use the standard template library, for example. So we haven't talked about Objective-C's containers. So with C++ we've got vectors and maps and queues and stacks and all sorts of good things, and Objective-C or Cocoa has its own set of libraries where you have NS array, NS mutable array, NS dictionary, NS mutable dictionary. So they have their own containers which are equivalent. But there are situations where I found that some of the algorithms and just some of the containers in the standard template library just are better suited to the problem at hand. So that's why I'm taking the time to show you this, because you might run into situations, or it could be that just at the beginning you're just more comfortable using some of the containers you're familiar with versus some of the Objective-C stuff. So if that happens, then you can use this. And something happened here. Yes?
How much can you intermix
C++ and Objective-C? Can you store a bunch of Objective-C objects inside of a vector, for example?
Yes. So you can intermix these quite a bit. What you can't do, so right now we're sort of doing, here's an Objective-C class that's including some C++ instance variable. You could do the other way around, where you have C++ that includes Objective-C stuff. The only thing you can't really do is, and again, at the end of the day, it all becomes Objective-C++. It's not C++ or Objective-C. But what you can't do is you can't have Objective-C objects inherit from C++, or Objective-C classes inherit from C++ classes and vice versa. And I'll show you in the documentation, there's a little snippet that pretty much shows you the general rules. Okay, so this didn't compile. And it's not because I messed up Objective-C++ stuff, it's just because I'm not including a header file. And if we look here, this thing's just like, cout was not declared. Okay. So I just need to go ahead and include IOStream. And that all builds. And if we run this, we should hopefully see nothing on the iPhone. And in our console, we should see our little 1, 2, 3. So that's, I think in general this is the direction or the way you'll be using C++. So let me show you some of my code. Yes?
How did you bring it to the debugging console?
Oh, debugging console. So when you actually, so right now, when you actually run the application using, say, build and run up here, this little toolbar will open up, and on there you'll see this like little GDB show console thing. So if you go with, click that and it'll open it up. The other option, so now we're done, and that thing goes away. If you go up to the run menu, under you'll see console over there, and it'll bring it up as well. So let's see. Let's look at some of my code that just to see how I've done some stuff. Now, some of this code is ugly, but I will say it's ugly, but it's generated some good cash. So, so it's important, right? For us being sort of the computer scientists that we are, we get very stuck on getting the best implementation or the most perfect thing or something that looks beautiful. And that's great, and we can all pat each other on the back and stuff when we do that, but the customer, they don't care. They don't care that it's spaghetti code, that it's the most beautiful, most elegant, make you cry code ever. It doesn't matter. All they care about is that they paid their 99 cents, which I wish it was more, but they're paying their 99 cents these days, and that the thing works, that it doesn't crash. That's all they care about. So one of the folks that's going to come in and talk to us, basically he has a great talk on this sort of stuff, and hopefully he'll be able to get in here before we start figuring out what projects you guys want to do for your final project. Yes? Colin? Colin Donnelly? Yeah. So there's I have a friend who lives in Sacramento that soon will be moving. So before he moves, hopefully, he'll come in and do a few lectures. He might do something on core data, which is some stuff we'll look at. But the gentleman I'm referring to, his name is Dave Watley, and he has, he'll be. The talk I saw a week ago that he gave was how to make, I think it was called How to Make Mad Money Selling iPhone Games or something. And he discusses one of these aspects of, if you're diving into like assembly language programming type stuff, you're probably just like, I don't know. It might be important for what you're doing, but chances are it's not. Anyways, we'll see him when he gets here, hopefully. I got to talk to him and see when we schedule that. Okay, so here I have a little library that I call Peanut. It's the Peanut word engine. That's kind of what I christened it long ago. It's basically a bunch of things that, there's an anagram solver, there's these lexicon things, whatever that is, there's this LexMe solution. And basically it's just a bunch of algorithms and data structures that let me manipulate strings and grids of strings for, say, solving word games. And some of this code, if some of you remember the Palm, and not like the new Palm Pre, but like the old school Palm, that stuff. So some of this code was running on that back in the day. So it was, So that was on a 2 megabyte device that was running at 16 megahertz. And I poured it over here. It runs 100 times faster. I didn't have to do anything, just compile. So you see, basically, I have a bunch of C++, and so I guess my code's not that ugly. Look, I have like comments and stuff. Look at that. And standard C++ type stuff. So the reason I'm showing this is just to show you that you can use C++, and then at some point, let me see where I actually include this. If it's in any .m files, Lexme board. Well, this file isn't directly included anywhere of importance to us right now, but eventually some of these files are included in these .m files, or if you look, so I've got a mix of .m and .mm files. So again, I kind of jump into the C++ wherever it's important, and where it's not, I stick to Objective-C. Yes?
Yeah, and in that case, then what are some of the situations do you run into where the C++ tends to do things that you're unable to do in regular Objective-C?
Okay, so some of the situations, and I actually have, when would I want to use C++ versus using Objective-C? So I mentioned one of the places is the standard template library. I think, if you know how to use the STL, it's fantastic. There's a bunch of algorithms, all sorts of great stuff. And I think this anagram solver might be a place where I was using it. Yes. Yeah, so here's an example. And maybe you can do this in Objective-C, and I just didn't know how to do it. But set difference. That's something that STL just had, and I needed it. And so, I got my words, I sorted them, and then I have some other things, these tiles, and for whatever reason I needed to do some sort of set difference. And yes?
So it's not that there's functionality that can't be made in Objective-C, it's just that sometimes there's a library.
Right. So you can implement set difference in Objective-C if you felt like it, but yes?
I'm really curious how you call C++ in Objective-C. So when you add functions, can you find an example where you did that?
Sure. Sure, let's see here. So let's look for a Lexme solution. So hopefully, this is a game in progress that I'll be eventually selling on the App Store. So whoever's looking at this, you're not allowed to steal my code this way. Actually, I don't care. Use it. It's whatever.
You'll have it done before we go.
Probably, hopefully. Although I've been kind of busy lately. So, okay, Lexme solution. Okay, so let's see if there's a different place. Game scene. All right, so yeah, I'll show you guys what this is. All right, so actually, I think so. It's 6. We're gonna stick around and do more stuff, but I need to let our friend, I think Rachel, right? I think I need to let her go. So we can go ahead and turn off the video, and then if you want to stretch out or something, feel free. Let's take like 5-10 minutes, and then we'll look at more of this, and then we'll do some coding, and yeah. We're not going to stay long.